Guys, previously we learned about the GC-MS system, gas chromatography mass spectroscopy, and we talked about its purpose. What does it do? And how is it different than just a regular old GC? And we said really the MS is the detector unit, and it sees things, and it reports me formula weights of molecules that get sent through. And if it matches up to what I think it is, then it's a good indication that that particular molecule is present. It reduces my workload in a way, and you'll learn more about that later on in the program. But while we're talking about the GC, I also want to talk about two other attachments that we have in our laboratory on our GC units. And one is called a Purge and Trap, and I'm going to abbreviate that as PT. And the other one is going to be called a Headspace analysis. So Purge and Trap and Headspace. And we got to talk about what the purpose of these are. I'm going to start with Purge and Trap first. Purge and Trap is basically an attachment that will feed into a GC system. And then if it goes into a mass spectrometer, it can at that point, or if it just wants to stop at GC, it can at that point too. It doesn't really matter, but it is a Purge and Trap system. The definition of Purge and Trap, it's basically in the name, okay? So what happens is that I have a sample, and let's say that this is a liquid sample. What goes on is that I have helium that requires the GC to work. And in the Purge and Trap system, helium also goes into the Purge and Trap system. So what happens is that a sample of liquid is sucked up and it is sent into a P&T tube. That represents a glass tube inside of a bigger attachment piece, okay? And helium will be bubbled through that sample. And the purpose of the helium is to purge. We call this Purge and Trap. That's the purge part. So all of the purgeable organics will leave, and they will be, guess what? Trapped onto another piece in the instrument. So the sample gets sucked in to the Purge and Trap unit. Helium is bubbled through the sample. Think of it as putting a straw down into soda and blowing through the straw. What's going to happen? You're going to make the soda probably go flat. And the reason is because you're forcing out all of the carbonation. Same type of things happening here. We're forcing out all of the carbonation, but in our case, we're forcing out all of the purgeable organics. All right, so those purgeable organics, they've got to have somewhere to go, so they get trapped onto a different part of the machine. And then when they get trapped, this thing is heated, and it releases the trapped molecules, and it releases it into the GC system. And then the GC will take over, and it will separate them just like always. The detector sees the pieces as they come through. And the detector can be a number of different ones. Mass spec is only one of them. Well, that's the purpose of Purge and Trap. Nothing more than that. Okay? Now go back and take another glance at the TOC notes that you've taken. The TOC measured non-purgeable organic compounds. So it took a sample, it purged it, but it purged it with air, not helium. It got rid of the volatiles, and out they went. And what was left over was the non-purgeables, and this is what TOC analyzed. Well, the purpose of this Purge and Trap instrument, it does something similar, but it's the other half of the story. One is the cup half full, one's the cup half empty. Meaning the TOC is going to measure the non-purgeable half of the sample, and the Purge and Trap will focus on the purgeable content of the instrument or the sample. All right, and that's all there is to it. That's the only purpose in it. It's mainly used for environmental, and that's where we're going to find this most of the time. The environmental aspect of the Purge and Trap systems Those are very volatile as far as the types of compounds that we're looking for. They are very well suited for this type of analysis, and it allows me to basically separate the components that I want to measure from the aqueous sample. Very often water is bad, okay? And water should not be injected directly on the GC system. It will actually destroy it. Slowly but surely it will destroy it. So I need to figure out a way to get those components out of the aqueous solution or out of the water. Well, this is one way that I can do it. It's the purge and trap system. So again, purging, bubbling out all of the volatiles that might be present, trapping those volatiles until that process is over, and then heating that containment unit up and releasing those into the GC for the analysis. That's what purge and trap is. So our purge and trap is actually attached to the GC-MS system. That's just how we decided to use our P&T system whenever we do decide to use it. We rarely do use it, but we do have that option for us that we can do. So not a big deal there, but that's the purpose of the purge and trap. Now let's turn our focus to the Headspace. The Headspace is also attached to a gas chromatography system in our laboratory, just like the purge and trap is. But let's talk about how the Headspace is a little different. So in the Headspace, I typically have a liquid or a solid substance. Okay, I can measure either one here. And what happens is that this vial goes into an oven. And it will sit there and it will heat up. Now the good thing is that if it's a liquid or if it's a solid, it doesn't really matter. It's both going to get warm, it's going to get toasty, it's going to get happy. But there is a cap on this vial. There's a cap on the purge and trap vial too. But there's a cap, so it's not going to go anywhere. All right, I'm not going to lose any sample right now. Only thing I'm doing is putting it into a nice little jacuzzi. That's it. Because sometimes the molecules need a little bit of heat to go volatile. Okay? The purge and trap system doesn't quite do that. The purge and trap system does not really have an oven. The only thing that it's doing is that it's purging volatile organics out of the sample and trapping them. And it's only really doing that through the process of a little bit of helium. Well, the Headspace analyzer, it will actually put it into an oven and it will heat this sample up to as hot as I need it to be heated up. That sample gets heated. My volatiles really do turn into a gas form at this stage. And then on the inside of this oven, there is a needle that will eventually puncture the vial that my sample is in. And it will suck out only the air, the vapor, the gas from that container. And it sends it into a GC system for analysis. That's the only difference. All right? So Headspace is great for the organics that are volatile, but maybe not volatile at room temperatures. Maybe they need a little bit of heat. Maybe they need a little bit of warmth on their feet to get them a little happy. That way they can volatilize into the vial, go into the gas form, and get sucked out of that sample and into the instrument. So that's how those two are going to be different. The purge and trap system. The purge and trap system landed us about $25,000 for that attachment only. The purge and trap system does have a auto sampler on it, and I think this auto sampler can hold around 72 different vials, I believe. It could go up a little more than that, but I think it's in the 70s. As far as the Headspace analysis, this Headspace unit is basically an attachment as well, just like purge and trap. So you typically have to buy it a little separate. This Headspace unit is about 40 grand, 35 to 40 grand, depending on what type of Headspace unit you have. So for instance, if you go to a car lot, do you get one with cloth or do you get one with leather? right? The same type of thing happens here with all of our equipment. Do we have one with cloth or do we have one with leather? What are the bells and whistles associated with this instrument? Well, ours was around 40 grand that we sunk into this. So that is an attachment onto a GC that we have in the lab. So in actuality, one of our GCs is a standalone with nothing else attached to it. And we use that for very simple samples, simple processes, especially in the very beginning. We have another GC that's a GCMS system. And the GCMS system does have the purge and trap attachment if we need to use it. So when we use purge and trap, we go to our GCMS system in order to get that done. And then we also have a Headspace unit, and the Headspace unit is attached to another GC that we have in our lab that we don't really modify or change. That's kind of its dedicated purpose. That's why we use that GC. And that GC has a different detector on it. So we got a couple of different options in our laboratory, and you'll get to use every one of them. But that is the purpose of a purge and trap, and that's the purpose of a Headspace analysis. All right, now let me show you some of the websites that you can go to learn more about each one of these guys. So for the purge and trap unit, I would like for you to go to the actual website, the actual model that we have, and this is Teledyne Tekmar. Teledyne Tekmar is the company that made the purge and trap that gets attached to the GCMS system. Okay, so again, think of it as an attachment, and Shimatsu, which is our GCMS manufacturer, does not make purge and trap systems. What they do is that they pair up with Teledyne Tekmar, and they say, we want you to do a model that is compatible to our instrument, and that's exactly what they've done. So Teledyne Tekmar is the manufacturer of the purge and trap system. Up here at the very top, you're going to go under products. Teledyne Tekmar, by the way, is teledynetekmar.com. So if you do want to go to the website, that's their website address. It's just the name of the company.com, and you got it. So under the product tab, there's a couple of different things that are under here. And one is called the volatile organic compounds, or VOCs. That is what we label these molecules that can be purged out of a system very easily. They are called VOCs. So volatile organic compounds. It just simply takes a little bit of helium bubble in order to get them to be released out of the sample and into the machine. There's no heat that's really required. They can trap, and that's where the heat comes in, to get them off the trap. But to get them out of the sample, no heat is required at all, okay? So our model is actually not listed here. We have a discontinued product. They no longer make it. It's a little bit older. I'm going to say that our purge and trap system is about 8 years old. So no longer do they make this specific model anymore, but they make something that's similar. So I'm going to click discontinued products. And what you will find, the discontinued products, would be right here. This is a Stratum purge and trap concentrator. That is the purpose of this piece if you see it in our lab. So it says the Stratum purge and trap concentrator, PTC, they add the C on, is a sample preparation instrument used to remove volatile organic compounds out of aqueous and solid sample types using helium or nitrogen. The VOCs are deposited onto a sorbent trap, which is then heated, releasing the VOCs into a gas chromatograph system. It says it's standard for many EPA methodologies. That's Environmental Protection Agency, right? That's the EPA, so that's why I told you that these are heavily used in the environmental field, as well as analytical options where concentrations of VOC is required. So they have been the leader in the purge and trap world since it was first released since the 1980s. So Teledyne Tekmar is probably what you'll see in a laboratory somewhere when you get a job, and that's why we chose the manufacturer that we did. All right. Down here at the bottom, it says that these are some of the applications that you might find. Environmental, of course, food and beverage, forensics and toxicology, pharmaceutical, and petrochemical. So again, I can click the application note page to figure out what else they do with this instrument, and maybe see if it's actually usable in my laboratory or not. So you'll eventually get to run samples using the Purge and Trap. Eventually, we'll get there, but that's what that thing looks like. Now, I don't know about you, but for me, I don't want to sit there and inject one sample after another and watch it purge and watch it bubble and watch it heat. And, that process takes about 15 to 20 minutes per sample. And I don't really want to go through that with every one of them. I want this to be somewhat automated. So because of that, we have this Aquatech 70 vial auto sampler. I told you 72, but I guess it holds 70 vials, not 72. Okay. So this is the auto sampler unit that we have onto that GCMS system that's connected to the Purge and Trap. So this is the auto sampler for the Purge and Trap unit that will eventually go to the GCMS unit. So it says with the Aquatech 70, you can achieve the highest sample throughput on the market. Throughput just basically means how fast can we process samples, right? How long is it taking us to process a sample from front end to back end? Obtain maximum sample capacity and throughput and improve your laboratory productivity with 70 sample positions. Aquatech 70 automatically measures the sample from each vial. It adds a standard solution and then transfers it to a Purge and Trap sample for analysis. So it's just a little bit of automation for me, but that's what that piece is in the laboratory. If you come into the lab one day and you see that sitting around on the countertop, that is the auto sampler for the Purge and Trap system. Now, what about the Headspace unit? What about it? That does not come from Aquatech. All right, that comes from somewhere else. So if you go back to the Agilent's website, because it's connected to our Agilent GC, you will be able to find the model of the Headspace unit that we have in our laboratory. So the way that you get there, if you look up here, the order that I've clicked, you go to the home screen, click under products that we've done before already, and then you're going to click the gas chromatography section because we're working in gas chromatography, right? So hopefully that makes sense. Under gas chromatography, you'll see some instrumentation that they will have. They'll have some fancy pictures beside of it, but there's going to be a link, and that link is going to say sample preparation. Because that's what this thing is. That's all that it is. It's just preparing a sample for analysis. Normally, I would have to do this, but I don't want to do it. I have an automated process that does it for me. So back in the day, I would have people working in a laboratory, and they would be heating these samples up on their own and pulling the headspace out of the sample vial and shooting it into the machine. No longer do we have to do that anymore. That's the purpose of this Headspace, right? We put automation to it. So sample preparation is the link. And G1888 Headspace sampler, that is the unit that we have. And there's a picture of it over here to the right-hand side. So you see the auto sampler tray basically that's loaded up here on top. Underneath this hood, that is where the sample goes, and it lowers down into the machine, and this is where the oven is at. So that's where it's going to be heated up, and that's where all of the more stubborn volatile organics will be heated and released into the headspace of the vial. And then from that point, that vapor will be sucked out of the vial and it will go into the machine. So Headspace sampling allows you to introduce volatile organics automatically from virtually any sample matrix directly into a GC or a GCMS. The Agilent G1888 Network Headspace Sampler features an inert sample pathway for chemical performance without worrying that your analyst is going to change or decompose on you. The high sample capacity and increased sensitivity provides excellent performance over a wide range of analyses. The total solution from sampling to data analysis to reporting gives you highest confidence in your results. So that is the Headspace unit. Here's a different picture of the Headspace. This is more of an updated one with the Agilent stamp right here across the front. This one is the same picture. And the one that we have does not have the Agilent piece up here at the very top, but it is the same model number. So Agilent kind of acquired these over a course of time, and that's why you're seeing their stamps on them now. Okay, here's another picture of the Headspace unit that's connected to the GC system. So over here to the left is going to be the Headspace unit. This is where the heating and stuff will take place. It turns into a gas. That gas basically goes through this tube and into the GC box, which is right here to the right-hand side. That door opens up. That's where the column would be, which is where all of the components would get separated from. All right. And then this piece here in the center, that's going to represent the detector. If you've got a detector here, it could be a mass spectrometer. It could be a different type of detector. And if so, then that is the attachment that we're seeing right there. Okay. So there's just another view, more of a front view of the Headspace unit itself. Down here at the bottom, you're going to see features, literature, support, promotions, and services, just like you've seen on every other piece of instrumentation page that's out there. So go through, click on some of these if you want to learn more about it. And then, of course, the features here is them trying to sell it to you. So why should you buy their Headspace over someone else's? Okay, so that's a little bit about the Headspace and the Purge and Trap systems in a laboratory. So again, the way this process is going to be set up, you're probably going to see some exterior YouTube videos. It's going to be about the equipment, about processing, and then I might upload a couple of documents for you to read, and then go in and start answering the questions for the assessment. So in the next video, I'm going to continue on with Agilent. We're on a roll, right? It seems like Agilent's showing up more and more, as well as Shimatsu, but it seems like Agilent's kind of becoming more and more commonplace now with our descriptions. So there's one more piece that I would like to talk to you about Agilent at least before we move on with some other pieces of equipment.